In this video for section 4.3, we're going to look at some patterns in logs to identify some properties of logarithms. In later videos, we will use these properties to expand and condense logarithms. So we're going to start by filling in these charts with the logarithms and noticing some patterns. I've already filled in these values. You will need to fill them in on your own in the activity. Use your calculator and just type in log of 12, log of 3 plus log of 4, etc. And you should get these values here. So you should pause the video and do that on your own first, and then resume when you are finished. So looking at this table, I see that there are some values that are the same. I know that log 12 is the same as log of 3 plus log of 4. Log of 9 is the same as log of 3 plus log of 3. And log of 18 is the same as log of 6 plus log of 3. So now we're going to complete this equation, log of x plus log of y. So what I should notice here is that when I take two logs and I add them together, it's the same as if I take one log and I multiply the two numbers together. So 6 times 3 is 18, 3 times 3 is 9, and 3 times 4 is 12. So for this equation, I could say that log of x plus log of y is equal to log of x times y. I'm going to highlight this in my notes so that I can refer to it later. So if I want to find the value of log of 30 and the 3 button is missing on our calculator, well, I could think about how could I make log of 30 out of two other logs that are added together. Well, I could use log of 5 plus log of 6, because 6 times 5 is 30. Or I could do log of 15 plus log of 2, because 15 times 2 is 30. I could also do log of 3 plus log of 10, except if the 3 button is missing, then I can't do log of 3. So I'm looking for a set of numbers that doesn't have a digit of 3 in them. So now let's look at the next table. Again, I've filled this in already, so you will need to fill it in on your own first. And then let's look at what we have here as far as patterns. So we have log of 5 is the same as log of 10 minus log of 2. Log of 7 is the same as log of 28 minus log of 4. And the log of 1/2 is the same as log 3 minus log 6. So what you are hopefully noticing is that when I subtract two logs, it's the same as when I put them into a single log and divide the two numbers. So log x minus log y is equal to log of x divided by y. And I'm going to highlight that one as well. How could we find the value of log 30 if the 3 button is missing on our calculator using these properties? So what I need is I need two numbers that when I divide them, it equals 30. So we could do log 60 minus log of 2. We could do log 120 minus log of 4. There's lots of possibilities as long as the two numbers divide to equal 30 and we aren't using the digit of 3. And finally, we have this table. So we have 2 times log of 5, log of 5 squared, and log of 25 are the same. We have 3 times the log of 4, log of 4 to the third, and log of 64 are the same. So what I'm noticing here is that when I have the number in front of the log, that's the same as putting that number as the power on the number inside the log. So the 2 here can move from the front to become a power on the 5. And we know that 5 squared is 25. Same thing for this second set. The 3 can move to a power on the 4 and become 4 to the third, which we know is 64. So using the patterns in the table, I can say that log of x times n is the same as log of x to the n power.